So the question is, a unity feedback system has an open loop transfer function. With an open loop transfer function, g of s is equal to k divided by s into s square plus 4s plus 13. Sketch the root locus, that is our question. So g of s is given and the system is having unity feedback, that means h of s is equal to 1. So the open loop transfer function of the system, that is g of s into h of s, that is equal to g of s itself, that is k divided by s into s square plus 4s plus 13. Now we have to find the open loop poles and open loop zeros of the system. So we know that here in the numerator there is only gain k. The open loop pole m is equal to 0. Number of open loop poles are not there. There is only gain k in the numerator. Hence open loop pole m is equal to 0. Number of open loop zeros m is equal to zeros. Now we have to find the number of open loop poles. So in the denominator of this transfer function, we can see that the system is having, the open loop system is third order system. Hence the number of open loop poles of the given system is 3. That means since the open loop transfer function is of third order, n, that is the number of open loop poles, is equal to 3. So the total number of open loop poles is 3 and open loop zeros equal to m equal to 0, because there is only gain k in the numerator and this gain k is the varying parameter. So we are plotting the root locus varying the gain, or the root locus is the variation of the locus of roots when the gain k varies from 0 to infinity. Now what are the open loop poles of the given system? We have to find the location of open loop poles. So we have the equation s into, in order to find the open loop poles, we have to take the denominator of the open loop transfer function, that is s into s square plus 4s plus 13 equal to 0. So from this we will get s is equal to 0, that is the first pole, and by solving this quadratic equation, that is s square plus 4s plus 13, on solving this quadratic equation we will get the open loop poles of the given system is at s is equal to 0, minus 2 plus or minus j3. On solving this quadratic equation and finding the roots of this quadratic equation, we will get the open loop pole location as 0, minus 2 plus or minus j3. So the next step is to locate all open loop poles and zeros in the graph sheet or S-plane. So here we don't have any open loop zeros, so we need to plot, or we need to locate only all the open loop poles. So the first open loop pole is at s is equal to 0, that is here. This is the location of one pole. You can see that okay. So you can see the location of one pole, s is equal to 0 here, and the location of another pole is at minus 2 plus j3 and minus j3. This is plus j3. So one pole location is here and another pole location is corresponding to this point, that is here. So this is minus 2 plus j3 and this is minus 2 minus j3. So mark all the open loop poles and zeros in the graph sheet. That is our next step. Then when we draw the root locus will be always symmetrical about the real axis. That is a property of the root locus. The root locus will be always symmetrical about the real axis. Now we have to find the locus of roots on real axis. That means if there is any root locus branch or root locus segment that is in the real axis. So in order to find that, what we have to do is we have to take any of an arbitrary checkpoints in the real axis. So we have to select any arbitrary checkpoint, and here I am taking the arbitrary checkpoint as -1. Okay, I am taking this as the arbitrary checkpoint. This -1 as arbitrary checkpoint. So now to the right of this, okay, to the right of that point, what is the total number of real poles and zeros? So to the right of this -1, we can see that there is only one pole, that is at s is equal to 0, which is an odd number. That means that this -1 point is included in the root locus. Again I can check from -2. When I take the arbitrary checkpoint as -2, then also the total number of poles and zeros on the real axis, okay, total number of open loop poles and zeros on the real axis is again 1. When you take -4, then again the total number of real poles and zeros to the right of this -4, that is when you take this -4, take the right side of this -4, and the total number of poles and zeros to the right side of real poles and zeros to the right side of this -4 is again 1. Hence since it's an odd number, we can see that these points are included in the root locus. So if you take any point in this negative real axis, okay, if you take any point in this negative real axis, you will get to the right of that point there is only one real pole. The total number of real poles and zeros is equal to only 1, and hence starting from 0, starting from here, that is 0, to the negative real axis, that is going to infinity, that is included in the root locus. So the entire negative real axis is included in the root locus, that we can plot now. So the root locus here, we can see that this point is included in the root locus. Starting from 0, this is included in the root locus. This is going up to negative infinity. So here, how many root locus branches are there? How many root locus branches are there in this question? Since there are 3 poles, since there are 3 open loop poles, 3 open loop poles, number of root locus branches equal to 3. Okay, there will be 3 root locus branches, and we know that each branch starting from the pole should end at 0, whether it can be finite 0 or infinite 0. So here in this question there are no finite zeros, because there is only gain term k in the numerator. So there are no finite open loop zeros. That means we have n minus m root locus branches n minus m root locus branches that will end at 0 at where infinity. So, from each pole there should be a root locus branches starting from each pole, and that root locus branch should terminate or end at 0. If there are no finite zeros, these root locus branches may end at the zeros at infinity. So, here we can say that the n minus m root locus branches that will end at the zeros at infinity. So, here we have n is equal to 3 and m is equal to 0. That means our 3 root locus branches will end at 0, that is at infinity. And our first branch of root locus is, that is starts from s is equal to 0 and it is ending to the negative real axis.